What is the best classification metric? Which one to use? Hi, before getting into the classification metrics part, let me give you a very brief idea about machine learning, the types of machine learning, and what are the different problems that we solve in machine learning. Well, I don't want to make it a boring lecture, so I'll quickly wrap up this introduction part. So machine learning is basically of three types. One is going to be your supervised learning, one is going to be unsupervised, and one is going to be reinforcement learning. We also have a semi-supervised learning part, which is a combination of supervised and unsupervised learning. Now, jumping into the supervised part, supervised learning is that learning where we deal with labeled data. That means the data is labeled. Now, again, in supervised learning, there are different types of problem that we solve. Now, one of these problems are classification and one of these problems are regression. These are the two problems that we solve, right? Now, in this video, we are focused more on the classification part. So what exactly is classification? I assume if you have clicked on this video to know more about the different classification metrics, which one to use, which one not to use, why am I boring why am I boring the lecture by talking about classification? That's an assumption that you already know. So I will not waste much time explaining about classification, but just 2 more minutes for the people who have no idea about classification. Now, classification name itself is very simple. We want to classify objects. Now, just imagine this scenario where you have 10,000 patient data, 10,000 patients. Some of them are diagnosed with cancer and some of them are not diagnosed with cancer. That means there are two categories of people, cancerous and non-cancerous. You take the data to the model, build a model in such a way that the model understands the pattern of the data. It understands the characteristics of people who are cancerous, people who are non-cancerous, and then it creates a model which will be able to predict for a new patient. That's the whole idea of machine learning. Now, this is what classification is. When you deal with a case, fraud versus not fraud, diseased versus non-diseased, these are called as your binary classification problem. If you have more classes, it becomes tertiary, it becomes multi-class classification problem as well. So this is a brief idea about classification problems. Now in this class, we will be talking about a very generic data set, which is breast cancer data set. And even I'm not going to load, like I don't have a CSV file. I'm going to use the existing toy data sets and I will show you how the metrics works. What are the different metrics in classification and how they work. So I'll quickly run this code so that my data set is ready. So we are loading this data set from the sklearn datasets. It will hardly take few minutes, and then I'll run this code, which basically means I'm storing the data into X and my target into Y. What is target? Cancerous or non-cancerous. Simple. So this is how my Y variable looks like, and this is how my X variable looks like. Nothing to worry about. A recommendation to you will be download the file which is present in the description below and run it in parallel with me. In that way, you will be understanding more. In case you have any requirements on a specific topic, maybe a project or into machine learning, anything, write down in the comment section below so that I can get back to you as soon as possible. Okay, now my data is read. Now what I'm doing is I'm doing a training and test split. See, these are very basic things. So I am expecting people to know about it, but if not, you are already watching this video. So training and test split ke baad, what I'm doing is I'm just checking the length of my data. So my length of the data is 569, training data is 426 and testing data is 143. After that, what I'm doing is I am running the feature scaling part where I am scaling down the values. What exactly is feature scaling? Probably I'll explain you in one of another videos, not in this video. So I'll move ahead, and this is how my scaled data are. Feature engineering steps, I have kept it empty because it will be a very lengthy process. In case you want to get into an end-to-end case study, I already have a video on my channel which you can simply go and check it out. It will be available in the I button, or else you can simply search for machine learning end-to-end Satyajit. You will be getting that video. Okay, it's a 3 hours video talking about an entire case study. Okay, let's not waste time. Get into the model part. Here I'm calling a KNN model, and the model's name is model. Okay, here I am calling model.predictproba. Predictproba is nothing but it predicts the probability values. And here, this is how the probability looks like. I'm also doing model.predict on the testing data. I'm little bit rushed, little bit fast, because I have to cover a lot of things, and people don't like long videos like 20 minutes, 30 minutes videos. So we'll try to wind it up as soon as possible. And this is how it is. And my accuracy is somewhat 95%. We'll quickly implement another model, which is decision tree. Same piece of code. I'm just changing the classifier name. That's it. So for the time being, you can see that my decision tree, my KNN gave me around 95% accuracy, and decision tree gave me around 89% accuracy. Right now, is accuracy the right term or the right metrics to use? Most of the times we get confused. There could be multiple scenarios as well, like imbalanced data sets. There could be many scenarios which comes in terms of machine learning. So people get confused which metrics to use. Well, looking at accuracy, definitely KNN is performing really better as compared to DT, decision trees. But is accuracy the best metrics? I personally don't check accuracy when the data set is not balanced. So again, there are two scenarios in machine learning. When you are dealing with a data set, your data set could be balanced, it could be imbalanced. If it is imbalanced, there are different techniques which we apply to make it balanced. Once your data set is balanced, then probably accuracy is a good metrics. But in case your data set is not balanced, then accuracy is called cursed. Okay, so we'll move ahead and we'll go through the multiple classification metrics. The first metrics I will talk about is, so these are the metrics that I will talk in this particular video. One is going to be log loss. One is going to be confusion metrics. One is going to be classification report. One is in confusion metrics itself, I'll talk about recall, precision, and F1 score. And we'll also talk about AUC, ROC. And which one of them is good, which one of them is not good, I will also tell you on the go. Now, log loss is the first type of classification metrics that I am going to focus on. Simply, what you can do is, log loss is a simple cost function. Okay, it's a simple way to find the error between your test data and your predicted data. So log loss formula is not that simple, looks doesn't simple, but it is very simple. It is minus 1 by n summation of y, that means the actual test, multiplied with predicted, log of predicted, plus 1 minus y multiplied with log of 1 minus predicted. That's what log loss is. Looks complicated, but when it comes to machine learning libraries, it makes our life easier to just implement the library and find the log loss. So here I'm implementing sklearn.metrics log loss, and I'm calling log loss on my decision tree data. What is my log loss value? 3.86. Now we will do the same thing for my KNN model as well, because we are running KNN and decision tree, right? So I will simply change this to pred, change this to KNN, run this, and then run the variable 1.499. So log loss for KNN is 1.44 and for decision tree is 3.86. So log loss is also telling that KNN is better than decision tree, at least in this scenario. Log loss basically means error. The more log loss, the worst your model is. It has to be less log loss. Okay. The second type of metrics I'm going to talk about is going to be confusion metrics. What is confusion metrics? Because it confuses people. Well, jokes apart, confusion matrix is a simple matrix very similar to this. Let's say I'm drawing a box. I am talking about fraud versus not fraud. Okay, so fraud could be my one case and not fraud could be my another case. Similarly, fraud and not fraud. This is my actual data. This is my predicted data. What is this box? This box basically tells you how many of them are actually fraud, actual fraud, predicted as not fraud, actual not fraud, predicted as fraud, and actual not fraud, predicted as not fraud. So the ones that are actually fraud and predicted as fraud are basically called as true positives. That means truly predicted as positives. The ones that are not fraud and predicted as not fraud, they are true negatives. That means truly predicted as negatives. This is how you can memorize. What is this box? Actual predicted as fraud means positive, but actual is fraud but predicted is not fraud. That means falsely predicted as negative. So it's going to be Fn. And this one is going to be Fp, falsely predicted as true. Okay, falsely predicted as positive. Now this is the definition of confusion matrix. Now simply if you want to find the accuracy from confusion matrix, you just add these two divided by the total number of attributes. That becomes your accuracy. In this case, it will be 46 plus 84 divided by the total values, whatever it is. Okay. So this is how you interpret a confusion matrix. From your confusion matrix, there are also some concepts like recall. Let me try it here. There are some concepts like recall and precision. Now, what is recall and precision? Recall is simply, let me just draw it here, this box. Recall is nothing but total positives divided by total positives plus false negatives. That means total positives divided by actual positives. Similarly, precision is going to be this box. Total positives divided by total positives plus false positives. True positives divided by true positives plus false positives. That means truly predicted as positives divided by all the records that are predicted as positives. So we also take care of these two features. These are very important metrics. We also compare recall and precision for both the classes and try to finalize which is good, which is not good. The next type of metrics is going to be classification report. This is personally my best metrics. I always go for classification report. The name itself is telling you report card, right? So it's a report card of your model. How to use it? Simply sklearn.metrics import classification report. Simply call classification report, pass your testing data and predicted data. So for decision trees, this is how my data looks like, which clearly means that the precision and recall is really good for the class 0. For class 1 is also very good. So you can basically finalize this model. This model is performing good. Now let's try to do it for KNN. I'll name it as CR2 and CR2. You can see this is where the difference comes. Here it is 86, 86, 86. For KNN, it is way better than the decision tree. 91, 91, 91. The recall precision and F1 score for KNN model is really good. So I will definitely go with the KNN model as per my classification report. Last but not the least, we have area under ROC curve. What is area under ROC? Now, area under ROC is a curve which is basically between 1 minus specificity and sensitivity. So here again we have to use the sklearn.metrics, ROC curve and ROC AUC score. I am calculating the score calling the decision tree model on the predict proba, and here I am calling the false positive rate and the true positive rate. I am calling the ROC curve and my ROC score is 88. So the more the ROC score, the better the model is. So this is for decision tree. We'll do the same for, let's try to do the same for KNN, AUC, ROC. Okay. Same piece of code I will copy, and copy, and just change the model name, change the value like the variable name for 2, name it as 2, 2 and 2, and name it as score 2. Simple. Sorry, this is not successful. This and this. ROC AUC score for KNN is really good, 97. So this is how you interpret your metrics. You create multiple models and then you, based on one metric, you try to check whether which model is performing well. Okay, and how to plot a graph? This is how you plot a graph. This is for decision tree. If you want to run the same piece of code for your KNN, you can simply do it for KNN. Anything else? No, nothing else. So this is for KNN. Now the important question is, again for accuracy also, you can use sklearn.metrics, accuracy, same piece of code. I will run it for my KNN. KNN is 95. Now coming on to the main and important topic, which metrics is best? It depends. You can focus on one particular metrics and compare multiple models. I personally go for classification report. I also check ROC AUC score as well. So you consider multiple metrics and then check multiple models. So the best metrics I would say personally would be classification report and AUC ROC. Apart from that, accuracy and all those things are not that important, because when you analyze AUC ROC and we analyze classification report, most of your doubts will be cleared off. You can easily identify how your models are performing. That's all about this particular video. As I have already explained that my machine learning playlist is almost ready. However, machine learning is available freely on multiple other YouTube channels as well. But on my channel, I will start publishing end-to-end machine learning videos almost every 2 days, only when I touch 20,000 subscribers. So keep supporting, keep following. In case you have any questions, any concerns, any requests, you know where to come. Comment section, comment it out, and it really helps me, because the more amount of comments and likes, based on the comments and likes, YouTube basically recommends it to other users. So if you think I'm really trying my best for all my viewers, all my subscribers, please like and comment on my video positively, and stay tuned. Keep supporting. Thank you. Bye bye.